Okay, everyone, welcome back to SAT Math. Today will be the week 5 lecture. So today, our first subunit is ratios, rates, proportional relationships, and units. Today will be a very short lecture compared to the other weeks so far. But we'll start off with understanding and applying proportional relationships. So we have this question here. The relationship between k and b can be written as k equals a times b, where a is a constant. If k equals 13 when b equals c, what is the value of k when b equals 1/2 c? So this question isn't very difficult on paper, but they frame it in a way that makes it difficult to understand. So when you get a question like this, pretty much the whole point is to just write down what you're given, because you'll have to end up using all of this information. So we get 4 main points here. We have k equals a times b, k equals 13, b equals c, and what is the value of k when b equals 1/2 c? So again, we can just start off by plugging in k equals 13 again, and then we can also just plug in b equals c. So we're just using what we're given, and we're looking for k when b equals 1/2 c. So again, this isn't very difficult. We just have to go about plugging it in this certain way. So when you have b equals 1/2 c, because we normally have k equals a times, well, c, because we can plug in b equals c, we can just multiply a 1/2 to both sides because of that 1/2 times c. Now, if that's confusing to you, just try and think about, we're changing that c to be 1/2, so we'll also have to end up changing that k to be 1/2 as well, because when you multiply, one side, you have to do the same thing to the other. So again, we just plug in k equals 13 here, and the answer is 6.5, just 13 divided by 2. So again, this is what I meant when I said the question itself isn't very difficult. They just frame it in a way that makes it hard to understand. So when you get a question like this that looks very complicated, just write down what you're given, and the answer might be simpler than you expect. Okay, moving on, we have solve using derived units or unit conversions. So we have this question about finding the ratio. If 35 fathoms is approximately equal to 63 meters and 115 fathoms is approximately equal to 690 feet, what is the ratio of meters to feet? So just write down again what we're given. We have 35 fathoms is approximately 63 meters and 115 is approximately 690 feet. So we want meters to feet, meaning when you have that ratio, you want meters over feet. So we first have to convert to like the actual units of meters over fathoms and feet over fathoms. So you can just do this math here by just, dividing what we're given. That will end up with 1.5 meters over fathoms and 6 feet over each fathom. So the reason why meters is on top is, again, we have that ratio of meters to feet, meaning meters has to be on top. And once you do this math, you'll just end up with 0.30, which is our answer here. Okay, subtopic 2, percentages. There's only this one, percentages, for this unit, so it'll be fairly quick. Over a 5-year period, the number of students in Class A decreased by 20%, while the number of students in Class B increased by 100%. Comparing the class sizes after this 5-year period, the number of students in Class B was 25% the number of students in Class A. If there were 40 students in Class A at the beginning of the 5-year period, how many students were in Class B at that time? Okay, so they give us a whole bunch of information, and again, we have to write it down. Now, Class A experiences a 20% decrease, and Class B experiences a 100% increase. Now, I like to think of percentages as fractions because I think it's easier for me personally. If you prefer using percentages, go for it. But Class A decreases by 20% or 1/5, and Class B increases 100%, which just means double. So again, you also have to know how to interpret these percentages. And increasing 100% means you double it. So after 5 years, Class B is 25% the number of students in Class A, which again for me helps me using fractions. So I say 1/4 times Class A equals Class B after this 5-year period. Okay, so how do we figure out how to solve this question? Well, they give us that there are 40 students in Class A at the beginning of the 5-year period. So we start off with 40 students that experiences a 20% decrease. So that will equal 32. And again, using that formula, Class B equals 1/4 times Class A, because the number of students in Class B was 25% the number of students in Class A after this 5-year period. We know that after this 5-year period, there are 8 students. Now remember, Class B doubled after 5 years. And this 8 student mark is after the 5-year period. So to find the students in Class B before the 5-year period, we have to divide by 2, which is our answer 4. Okay, some solving strategies. I'll mostly focus on units because I believe that's a lot harder. Percentages, I think there's more leeway because you can convert it to decimals or fractions or whatever is more comfortable for you. But understanding units takes a lot more understanding. So we have this question here, race distance. Mikhail is registered to participate in a 30-kilometer race, and he knows that 1 kilometer is approximately 5/8 miles, and he wants to convert it to kilometers to miles. So when you have this unit here, you have to line it up in a way where we get the desired unit, which is miles. So if you multiply 30 kilometers times 5/8 of a mile over 1 kilometer, kilometers will cancel out and you'll be left with 75/4 miles. So that is how you line up the units to find what you want. And remember, when you also divide with fractions, you'll have to change the units as well. So let's say this was 30 kilometers divided by 5/8 miles over 1 kilometer. Your answer would actually end up being kilometers squared over 1 mile, because you'll have to end up multiplying by that 1 kilometer and dividing by that 5/8 miles. Okay, this one should make more sense in terms of how to lining up the units. So we have this certain type of wood with a density of 37.5 pounds over feet cubed. A home improvement store sells pieces of this type of wood in the form of solid cubes that weighs 64.8 pounds each. What is the length in feet of an edge of one of the cubes sold at this store? So you have to read this very carefully. We're given feet cubed, but the question is asking just feet. So keeping that in mind, we'll solve for this question. So when you start off, again, just write down what you're given. We have the density, and we also have how much the cube weighs. So we want this in length in feet. So if you want to line this up like this, we have density, and this is what we're looking for. We just don't know how many feet are for each cube. So to find this out, you can either cross multiply, but I think this way is a lot better to visualize the units. So when you divide 64.8 pounds when you multiply 64.8 pounds by 37.5 pounds over 1 foot cubed, which is the density, you will end up having to multiply the reciprocal of that fraction, which is why you have feet cubed on top. And the reason why you divide 64.8 pounds by the density, not the other way around, is because we want feet. If we divide the density by the weight, we'll end up with feet cubed on the bottom, and that makes it so that we cannot actually find that unless we flip it again, which makes it very complicated. So this way will be a lot, well, this would be the correct way to solve it because we're looking for feet. So when you solve it this way, you'll end up getting 1.728 feet cubed. And don't think you're done. They will leave this answer choice on here if it's multiple choice. If it's fill in the blank, you will just get this wrong. Again, we're looking for length in just feet, meaning we have to cube root this. I forgot to write down the cube root, but we're supposed to cube root this. And you will have an calculator on the SAT, so you won't have to worry about that. And the correct answer will be 1.2 feet. Okay, so again, like I said, short lecture today. That'll be all. And if you like this video, please like and subscribe.